So in Chapter 2, we're going to be talking a lot about truth tables, and in future chapters as well. A truth table is a way that we can graphically represent the input values and the corresponding output values of variables. I can tell the number of rows there should be in my truth table based upon the number of variables that I am displaying and the number of values that each one of those variables can take on. So let's say that we have one decimal variable, we'll call it x, and because it's a decimal variable, it can take on 10 different values, 0 through 9. If it can take on 10 values and I have one of the variables, that means that there's going to be 10 rows in my truth table. So let's say that I'm going to draw the truth table for one binary variable. Because he's binary, he can take on either one of two values, true or false, yes or no. Because he can take on two values and I only have one of them, that means the truth table is going to have 2 rows. And finally, let's say that we're going to draw a truth table for two binary variables. Let's call them x and y. Because they're binary, they can take on two values. Because I have 2 of them, 2 raised to the power of 2 is 4. That means that when I build a truth table for two binary values, that's going to give me 4 rows. So let's see if we can draw a truth table for two binary variables. The first thing I'm going to do, we're going to have x, and the second variable is going to be y. I am going to put each one of my variables in a column, and then there are 4 possible options between the two of them. We decided that there's going to be 4 rows in my truth table. So what I want to do is have some kind of an organized way to represent all 4 rows. So the first thing I'm going to do is put down the values of x. Because there's 4 rows, x can take on the value of true and false, and then I am going to put in the value of y. So if I hold steady the value of x, false, false, true, true, and then I toggle the value of y, ultimately I should have 4 rows, 4 possible combinations, 4 values. The next column in my truth table is going to be output based upon those 2 particular input. And this output column is going to be based entirely upon what kind of an operation that I want to perform on these 2 variables. So let's say, for instance, that I wanted to add the 2 of them together. Well, that would be false plus true, because the value of x is false and the value of y is true. Then the second row would be false plus false. The third row would be true plus true, and then the last row would be true plus false. Now, we don't normally add binary values together, so I might want to perform an operation that I might see on truth variables. How about if we do equivalent? So we're going to say, is x equivalent to y? This equivalent operator we've learned is only true when both the values of x and y are equivalent or equal. Well, in my first row, I can see that false and true, the value of x and y, false and true, they're not equal, so I'm going to put a false in this row. In my second row, the 2 of them are the same. In my original columns, x and y are both false, so if they are the same, my equivalence operator is going to be true. In my third row, they are the same still, but now they are both true, so my equivalence operator is going to be true. And in the last row, they're not the same. The x is true and the y is false. Therefore, the value in this final column is going to be false. So a truth table is a really valuable tool that I can use when I want to see all possible combinations of input and what the output is going to be. As I said before, we can always double check ourselves to make sure how many rows I'm supposed to have. What if I had 3 binary variables? Because they're binary variables and I have 3 of them, that means that there are going to be 8 different rows in my truth table. What if I had 3 decimal variables? Well, because they're decimal variables, there's 10 possible options. If I have 3 of them, this is going to be 1,000. That means that I'd have 1,000 rows in this truth table, and I'm not sure how valuable that would be to me, but it's just one way that I can check to make sure that I have all of the possible combinations of input so that I can calculate what those output will be.